Okay. So far, basic lazy evaluation, if else loop. Okay. Now we'll start with the for today. How we can use for loop. How we can take some question, try to solve that question using Scala or Ripple. Okay. I'll open a Scala cell again. Terminal. All right. So here we'll see. We'll go to first downloads, then setup, then Scala, then bin/Scala. And here we'll see, well, x is equal to, so for loop thing we have seen, right, how we are using the for loop and printing those values which you're looking for, like modulus and all. Suppose I'm running a for loop and I'm actually doing an inner for loop. So I will have one loop, I is equal to 1 to 3, let's say. So I is having value from 1 to 3, which is 1 comma 2 comma 3. Okay, you can write this as I is having this value as 1 comma 2 comma 3. And then you can take another thing, which is, let's say j will have 1 comma 2 comma 3 comma 4. Okay, so I can write here for j, I'll say j is having, this is the assignment. So signature is important here, okay, because this is different from other programming languages. If you see this arrow mark and this hyphen, right, this means what? You are assigning this value, you're assigning this value to I. That's what it means. You're assigning this value to j, that's what it means. Okay, so we'll be writing here j is 1 until 5. So we know the until and to both the meaning. And then we said println I comma j. Now if I print this, what is our expected output? So this is like creating a matrix. Okay, this will create a matrix, and within that matrix it will store, if I run this loop, it will store, it will check first I value. So I value 1, j all the value, then I value 2, j all the value, then I value 3 and j all the value, right? So I will check this one against all the number. So 1 comma 1, 1 comma 2, 1 comma 3, 1 comma 4. Similarly, I will take this 2 against all the number, 2 comma 1, 2 comma 2, 2 comma 3, 2 comma 4. And then for the last number also 3 comma 1, 3 comma 2, 3 comma 3 and 3 comma 4. So basically this is like we are trying to multiply every element with other variable elements and trying to create one inner loop. So answer is known to us. This will create us 3 into 4, which means 12. Total result we will get 1 comma 1, 1 comma 2, 1 comma 3, and you can see the answer. Now, can I apply some condition here? Can I apply here if I is greater than equal to 2, then only do this. Otherwise, don't check this. Okay. Now, I is greater than equal to 2 means it will skip the first part and it will only check from 2 and 3. So I value 2 and 3. In fact, you can do this if condition also you can apply. When I and j both are equal, then only print. So in this case, it will be 1 comma 1, 2 comma 2, 3 comma 3. This is the only number where my I and j both are exactly equal to each other. So you can use this in multi-dimensional array if you want to traverse any element. We'll see that in in IntelliJ. Okay, how we'll be using in multi-dimensional array. Now, let's say I want to create a number. Well, create a question first. So this is my question. Question number one. Define 10 natural numbers. 10 natural numbers and sum them. So add them all. Now, if you ask me define 10 natural numbers, so what is the definition of natural number? The number which starts with 1, as in it starts from 1 and goes till the last element, which is 10. So if I'm creating this natural number, it will be 1, 2, 3, 4, 5, 6, 7, 8, so on till 10, right? This is what is one element. Maybe I can call it's a collection of element, collection of similar element. I can create this in array, list. There are so many collection topics, but currently this is, we have not yet seen the collection. That's why I will not use the collection. I will say this is n is equal to this number. I can create this number using 1 to 10 using range operation. So range will give me this number, and then I can say I want to add this number, right? So I want to do this 1 plus 2 plus 3 plus 4 plus 5 plus so on till 10. And first 10 natural numbers sum, if you ask me, it is exactly 55. Okay, so you can add this. We need to prove this. This is what is our expected output. You have to prove this number. You can take any sort of question for this, just to write some basic syntax in Scala. Now, how can I do this? I can do this in both the style, descriptive style and imperative style. Descriptive is well very easy. I can say 1 to 10 dot sum, right? Done. But there is no logic. You're using some inbuilt function. You're not using your own logic. You're using inbuilt function to access this variable. Now, can I write, I'll explain you all these terms. Can I write this? So what is this underscore? We'll see reduce part, okay? Separately. This is just a writing style currently. We can get the output. This is your descriptive style because you are using functions. So if you're a Scala programmer and you're claiming that you are a Scala guy, you should write your code like this. Then somebody asks you what is reduce, what is this, then you can explain. But if I want to prove this using some logic, I don't want to use the ready-made function, I want to use some logic. So I will do this. I'll create, well, n is equal to 1 to 10. I can do this. This will create me a range of 10. And then, well, s1 is equal to, well, s1 is equal to 1 to 10. Well, s1 is equal to, I will create one counter. Okay, so let me create a var counter. I'll say this is sum, this is 0, and I'll use a for loop. So I'll apply for loop where I is taking all the value of n one by one, and doing so this is sum plus is equal to I, right? So I value will start increasing, and after that I will print this sum. This is what is a typical coding style. So I have created first 1 to 10, then created one counter. This is a counter, and after creating this counter, I am writing this values. Okay, I'm writing this values for I is iterating or towards all the value of n, which is 1 to 10. Okay, So 1 comma till all the number is going to this high point, and then printing the sum. This is one thing. Now reduce, map, and filter. This three operation is very important operation in Scala, mainly for transformation. So we'll be using this thing for transformation. How can we transform any result? I will change the question. Now, before changing the question, I'll explain you this reduce part, how this reduce is working. What does this mean actually? So within reduce, what I'm writing is my lambda expressions. Okay. So instead of this underscore underscore, let me write some pair statement, x comma y and x plus y. I get the same answer. Now what I'm writing inside this reduce function is my lambda expression. Okay. And what this lambda expression is for, so we'll read this way, x comma y. Now this dot is a carry forward operator here. Remember, this dot, we can call it as a carry forward operator. It will forward whatever is input in the left side. It will take this and forward it to right side. So 1 2 3 4 5 6 7 8 9 10 is there from 1 to 10. Reduce is one function which does aggregation. Reduce is one function, is inbuilt function which does aggregation. Okay. And what is this aggregation? Uh, this is the same invite, Anshika. Same session invite is there, the one which we have used yesterday. It's not new. The one, I think you have joined the same one, right? Or did you join new one? It's the same invite because this is there for complete week. It's not changing day wise. Ask her to check. Ask her to check the same invite. Yeah. So reduce is doing the aggregation. Okay. And in this aggregation, we have x comma y and x plus y. Okay. How I'll take this two things. How I'll take x, y, and x plus y. So accumulator aggregation reduces aggregation, and it works pretty similar as accumulator. Now, what is the accumulator? We'll see this. Okay, what is this accumulator? So accumulator will accumulate their current value and the next value, and it will take x is equal to 1, y is equal to 2, right? Because if I take 1 to 10, it is 1 comma 2 comma 3, like this number is my 1 to 10 thing. So I'm taking x1 y2, okay, current value and next value, whatever is the addition of it, because that's what I'm doing. X plus y is 3, and this 3 is again assigned to x. So you're currently here, this x is again assigned to 3, so this 3 will be assigned to y again, which means you are here. 3 plus 3 is 6, so x is equal to 6. Whatever is the output is your current output. Okay, you can read like that. Then y will become 4, so y is 4. 6 plus 4 is 10, which will again assign to x, and y is equal to 5. X plus y is 15, which is new input for x. Y is equal to 6. Then 15 plus 6 is 21, which will assign to x. Y is equal to 7. We are here. Then x is equal to 28. Y is equal to 8. This is total 36. This output is again assigned to x. Y is equal to 9. And x equal to 36 plus 9 is 45, and y is equal to 10. And the final output x plus y is 45 plus 10 is 55 is 55, this one, right? So this is the accumulator concept, which will accumulate your previous value with current value. Whatever is the output will be assigned to X again. So what is the difference between sum and reduce? So reduce is doing aggregation, okay, but it can not only do plus, it can do multiplication, it can do subtraction, division, it can do all these operations. Sum is only doing addition, okay, that's the difference. Now, what is this thing underscore plus underscore? So underscore in Scala, remember underscore, let me write this as note, underscore in Scala is an interpreter, sorry, not interpreter, is an wildcard, is a wildcard characters. Now, what do we mean by wildcard character? Okay, what do we mean by wildcard character? Wildcard character means you can use this underscore at many places. Okay, so instead of using this x, y, and x, because these are anyway my arguments only, right? Anonymous argument I can call. So x and y and x, this values are nothing. That's why I'm removing this values, this values which I can call as operand. So I'm removing this operand with underscore, and I am removing this operand also with underscore. Only I'm talking about the operator, which is plus operator, assignment operator. So I'm only care about the operator, not the operand. So instead of operand, I'm using this underscore and underscore thing, okay, to get the output. So this is about your single question where we have asked define 10 natural numbers and sum them. Now let's say there's another question which says create or define 15 natural numbers. Define let's not say natural, let's say define 15 number which should start from 0, which should start from 0. And okay, so we'll give this instruction first, then second instruction which should start from 0 and find out only odd numbers. So we said define 50 number from 0 to 50, okay, 0 to 49, because 0 to 50 would be 51 number, so 0 to 49, and find out only odd numbers, not even numbers, okay. After finding the odd number, multiply all odd numbers, multiply all odd numbers with 2, with 2, and sum all of them, and sum all of them. So let's read again. Define the 50 number. We'll go one by one. If somebody is asking me to define the 50 number from 0, so I'll say n is equal to, let me change the color, n is equal to, this is my variable, which I can make as well where anything. I'm just writing a pseudocode currently, how I can fit in this data set. Then I will care about the syntax. Pseudocode means no syntax. So n is equal to 0 to 49. Can I see that? If it is in chronological, in a sequence it is going through, and find out only odd numbers. This is interesting, okay? Because here I need to use the logic of filter. But one thing is very important here. Would you suggest me to make this n as lazy? Because if I do not make this n as lazy, then what will happen? 0 to 49, all this number will take some space in memory. You have to think here. Obviously, first you can start writing the code and then later you can do optimization. But my first question is here. N is equal to 0 to 49 I'm creating. The moment I enter this, it will immediately assign some space in memory, which is RAM, volatile space, and it will send this total number to CPU for computation. But don't you think we are looking only 50% valid data in between this number? Because this is what we have said. Odd numbers, we only want to check, or we only care about the odd number, which are 1 comma 3 comma 5 comma 7 so on till 49. But still, if you check, if you consider this as 100% data, then don't you think you're only collecting 50% data and you're discarding 50% data? You're discarding the even numbers, you're only caring about the odd numbers, which means what is the use if I send all this data to my memory and CPU? Because I'm not going to anyway process all the number. I'm going to process only few number. So can I make this thing as lazy? Will that be fine? I think this is more computational, more fast, more performance performance optimistic, or optimizations we can achieve using this lazy concept. So you can directly define without this lazy also. You can see the performance. This is a smaller number. You may not see big difference, but if it is a very big value, and if you're creating lazy, but if I want to prove this using lazy, I can make a better statement, right? Because I'm not looking for 50% data. I'm looking only for data which are odd numbers. So why to send those even number to CPU, or in fact to memory also? But however, we cannot save, we have to send this to memory, but CPU time we can save. So this is what I'm trying to save using this lazy thing. Now, in first step, you have created 0 to 49. In second step, you're saying I only need odd numbers using whatever concept let's say you got this number, okay? Because in programming, there is not one method written for one answer. There's multiple approaches. Point number third, multiply all odd numbers with 2 and sum all of them. So they're saying me to do this. Multiply all odd number with 2. So 1 cross 2 as in multiply 2, 3 multiply 2, 5 multiply 2, 7 multiply 2, and this will go until 49. 49 multiply 2. I'll multiply this number, get the answer. This is 2 into 1 is 2, 3 into 2 is, this is the, I'm reading this statement by the way. Multiply all odd numbers with 2. So 2 into 1, 3 into 2 is 6, 5 into 2 is 10, this is 14, and this is 98. I'll be getting some number here if I eat this, right? So after this, you're almost done. Last part is again, sum all of them. So you can directly use sum. We have seen in the previous page what is the sum, or you can use a reduce. So ideally you need this 2 plus 6 plus 10 plus 14, and you need here plus how much, this is still 98. So we'll get some value as final answer. Now we'll try to build a solution. Okay, so approach is known to us now. We should always create approach like this. Then I can actually solve this in just one line. So first I will tell you that answer. How concise this is in a Scala. I want to create from 0 to 49 dot. I want to take those number which are odd numbers. Can I say this is I modulus 2 is not equal to 0? This is lambda expression. Lambda is anonymous. Okay, so here, similar as Python, we are not defining what is I. No need to call integer I. Okay, I understand, because also I started my career with Java. So when I started learning Scala, I thought, why we are not writing integer here? So Scala will skip all this area. Scala says you just write the name, rest I'll take care. Dot map, because I wanted to multiply all this number with, and you can type anything, okay, any possible letter from I to Z, A to Z, anything. Not necessary that we have defined this I somewhere. I'm writing this I here in the bracket. I'm writing this J here in the bracket. It's not defined anywhere. If you're thinking this IJ I'm taking, you can check this with some other name also. You can say M and N also. So this does not have any significance with previous variables. This is M, and just for confusion, I'm creating this M into N into 2. This is what I was looking for, to multiply with 2 dot sum. Or I can do reduce also, right? Reduce, because reduce is doing the same thing. Well, sum can also deal with it, because I am adding this to number, and here I can say a comma b and a plus b will get the same output. So in just one line, you have solved this problem statement. If I'm writing this with a typical approach, okay, what this three thing is doing, we'll see one by one. Filter, we know. Filter is discarding your result which are not passing this condition. Filter is discarding those results which are not passing this condition and only taking those values which are passing this condition. So filter is like 50% data it is removing in this stage. Afterwards, we have dot map n is equal to n into 2. So what this map does, whatever number is supplied after the second operation, it will multiply all the numbers with 2 and send it to this reduce, because we know this dot is a carry forward operator. So it will go to reduce and then start doing the accumulation. A, B, C, D, like that. So what is A, what is B, whatever is the output, then again A, then again B. I've explained this in the previous stage. This is one. Let's say I want to write some expressive level of coding, and you know the advanced Scala can read this in, this is like crazy. So if you think you're fine with this, you can write it. If you're thinking this is currently confusing, maybe once you are good, having good hands-on in a Scala, you can start using this. These are wildcard character. It will also give me the same answer, but this is not expressive. So I'll only recommend, I'm currently giving you this option also, because if you read the textbook, you will find oftentimes there is underscore. So do not confuse if you see underscore anywhere in a Scala. Underscore is for wildcard characters. Okay, we'll be using that for wildcard purpose. Now let me create one number with, well, x is equal to, or let me say number itself, well, num is equal to 0 to 49. I'm trying to use my imperative style, like typical loop style. Okay, so 0 to 49, and then here we want to take only the numbers which are odd numbers. Okay, so I will take one variable again as counter sum is equal to 0, and I'll take for loop, and then I'll try to iterate this to I with the times number 0 to 49 times, and within this then I will write logic. I'll say whatever number is coming, okay, whatever number is coming in I should have written if loop first. Let me write if condition here. If, okay, I'm writing one more loop. I'm saying for I number, if this I is divided by 0, then it's even number. If it is not divided by 0, then it's odd number. This is my logic. And after this logic, then I will write their print statement. Okay. So in print statement, actually I should have written this thing there itself in the for loop. That would have been an easier thing. Then 1 second, let me think. So it will take 1, 3, 5 from there and directly start adding it. Yeah, that looks more easier than this. So I'll discard this line here and try to write in this loop itself. So for is this number, and here itself I'll write this if condition. If I modulus 2 is not equal to 0, then sum is equal to, right? Sum is 0. So sum is equal to sum plus I. Take all the i's, whichever is passing. By the way, we are not multiplying it, so we'll multiply it also. We'll say this output will store in one variable called well multi is equal to, okay, well multi is equal, let me first write it, then I'll explain you maybe again. Well, multi is equal to I into 2. Okay. Well, multi is equal to I into 2. So all the output will store in multi. And then we can do, well, where m is equal to multi dot sum, and then print m. Actually, sum is defined already, so it's making this thing as 0. For writing this kind of code, I find IntelliJ is more good because here you see very less instruction. If this is working good, otherwise I will write this code in my other area of IntelliJ. Okay. So reduce, or let's first print this multi. We'll see what this multi is storing. So multi has 1 into 2, then 3, then 5. Multi has done the job, but just that you're getting in a confusing line. This is actually 2, 6, 10, 14, 18, but we wanted to add all of this number, right? So I into 2 will not help me. I can use the map operations here directly. So I think let's do this in IntelliJ. This is confusing 8 times here. I can prove this total point, which is equal to 12, 1250, but it can be a confusing here. So we'll see this in IntelliJ, okay? The same kind of question. Well, we get the answer of our question, what we can apply. For now, what is the takeaway from this point? Filter, map, and reduce. This 3 functions, filter, map, and reduce, these 3 functions are transformation functions. Very helpful, very useful in Scala. You'll be using them a lot when you're working with a Spark also. So these are transformation which we need at every place for aggregation or any kind of small work. Now let's go on to functions. So far we are only using the function which is defined here already by default, functions. Can we start creating our own user defined functions? Okay, so we'll see now how we can work with second type of function. So function, first type is inbuilt function, like reduce, map, filter, sum, length, all this that you're using is inbuilt function. Second function is a user defined function. So we call often this UDF, user defined functions. Okay, we'll create one UDF first. And before creating UDF, we'll see the function type or syntax. Function syntax. Okay, because if you don't know syntax, then how can you put this thing? You will type diff. This function creation of Scala and Python is exactly similar. This is how we create in Python also. So whenever Python is similar, I'll be relating. You have both the flavor. Diff, I'll write the function name, which can be anything logical to that application. Diff function name. You will pass argument here. Okay, so you'll say argument one. Can you call this as argument one? What is their data type? Because without data type, you can't store any value in any machine. Any programming language needs a data type, internally or externally, but we have to write this data type. So here in this Scala syntax, this is the difference. In Python, we don't need to pass the data type. Here we need to pass whether this belongs to integer, float, tuple, string. Now I'll not write any hard-coded data type. I'll say data type for now because I'm currently creating the syntax. Data type, whatever is there, you can put it here. Comma, second argument, right? If you need one argument, that's okay. You can close the bracket. Second argument, we will have to write how to go to the next line in Scala. So I'll just enter. Yes. Pressing enter, you can go. So argument one, argument data type one, then argument two, colon data type, data underscore type. Okay, this is your second argument, and is equal to what function you are creating for. This is the function body. This is the function body. Okay, so you're creating function for what purpose? This logic, the function logic will be written here. So whatever is the logic of this function, we will write in this function body, which will have this argument if required. Otherwise, you can pass argument as some other variable and you can use it also here. Not necessary that it has to be a part of function. There are several methods like constructors, different types of constructor, calling variable, calling arguments. We'll see all things one by one. So this is colon. What is the return type of this function? That completely depends on the function body. Remember, what is the return type of this function? It depends on this function body, what it is returning, and this two data type. So this two data type is similar. This will also give some data type based on this. This is the syntax for function creations. Okay. Now, before going to function creations, what are functions? So always we ask the question, what is this? Whatever we are learning, why we are learning this. So functions are created for reusability purpose. Okay, so I'm not doing the same thing again and again. I can use this ready-made code or ready-made piece of line to apply on my application. That's what the function definition I can give you in the plain layman terms. In textbook also, if you read, you'll find this function is designed for reusable purpose. I can again and again use this function to prove my concept. Let's take one example that I need to calculate. Okay, I'll have this question. I need to calculate. We need to calculate area of all the houses, all the houses, all the houses inside Trump Tower. So let's say Trump Tower has one building, one big building, and their total number of floors. So Trump has a big building. Their total number of floor we have, let's say 13, and each floor we have total 2 flat. So building is one, building is one, floor is 13, and total flat per floor is 2. Now, if I'm creating one project to calculate all the area of the area of Trump Tower, what is the total uh, empty space or lawn space? I can segregate them later on. First, I need to check the total area. I can create one area function, and this area function can check all the floor, all the flat, which means total 26 area, flat area it can check, just one function. I'm not creating this function 26 times, right? I'm not creating this functions 26 times because definitely all the floor, all the flat can have a different sizes house. Like maybe one has a 5,000 square feet, second has a 3,600 square feet, four has a 4,000 square feet, fifth has just a 1,200 square feet. So likewise flat we can have. So if I'm looking to count and check the total area, why don't I create a single function and pass these values one by one? So what I'm doing here, I'm doing reusable. I'm trying to get the reusability using this function. So this area is very common example. We can do any operations. So I sometimes feel people say functional programming is good. Definitely it is good. But you have to rectify. You have to remember these functions, which is not possible if you're working with multiple languages, multiple libraries. You cannot remember all the functions languages, sorry, all the function names of any library. What is important, you should know how to create your logic using this user defined function. Because if logic is clear, if this thing is clear, the business logic is clear, you can write anything, you can create any function. If the function is present and you do not remember the function, you can create your own function and use them. So let's see some scenario to create a function. Okay, I'll directly write here. I'll say um, well, diff will start with, right? So diff, what is the function name you want to create? Function name as, let's say, area. We'll create for area itself. Now you have to know this, okay? You should know what is this area formula is, because if this is not known, maybe you can Google it up, but logic you cannot Google. Google will not tell you the logic, Google will tell the syntax only. So we should know the formula for area. What things are required to calculate the area? And if I go to my school days math, I see in the 6th grade, area is equal to length into width, right? Any area is length and width or breadth, I can say, instead of width. So why I'm writing this formula? For a reason, because when you write this formula, you know, I need two argument. This is my argument number 1, and this is my argument number 2. If let's say somebody is asking you, find out the volume, then is in this volume you'll say, okay, I need now length also, I need width also, and I need one more factor, height also, to check the volume, which means total number of argument is changing here. Argument 1, argument 2, argument 3. Remember these points. This is writing, this is not that important. Okay, this is more important. You should know this part first. For any function, well, area and volume is very basic mathematical functions. I'll create it for area first. And yes, this, if this keyword is defined, then I should not use it. So if area is defined already as a function, I should not use it. It may throw me exception because result keywords you cannot use in your program. These are known as a result keyword. Well, area is not reserved by any library, hence I can use it. So area, or if there is already area, you can say area 1. You just have to change uh, the spell, or you can add any digit on that. I need two argument. I can name them ABC anything. I can say len also for logical. I can say L also. Let me call L. L for length. And what do you say? This is having float value. So data types a bit again. We have seen already so many data types in previous programming languages. So here I will be talking about integer, long. There's a big integer also from the same family of numeric. There's a float. There's a double. There's a string. There's a boolean. All these data types we can deal with. Okay. Now we have typecasting operation also. We can do typecasting here. Okay. So length is float and width, which is W, is also float. Can I give integer here also? Definitely I can do that. I can give any data type, guys. So since this is related to area, I'm expecting the value in decimal and I'm giving float and float for both the argument. Now what is a function body? Your logic is, how do you calculate the area when you multiply length and width? So you can say, this is your function definition, this is function name, this is function arguments, and this is function body. Okay, now you will have to say here also float. If you do not write float, it will take it. I'll show you. So if you check the second line, length is float, which I have defined, W is float, which I have defined, but this float, in this place, I can write float also, but Python Scala says me, no worries, I will return this float statement based on your to statement. So to argument data type is float and float, hence I'm getting this as a float. Now question is, if I type this as a double, let's say I'm typing one data type as a double, then what will happen? Yes, so if you use the result keyword, it will throw you exception in compiler. Not compiler, in fact, if you write in your IntelliJ itself will tell you that this is the result keyword. So we should be pointing our cursor more often whenever we get that red or yellow sign. Yellow is however warning thing. Red is your error or exceptions. So we should not compile our code if it has any red line containing in the code. From left side, right side, from debugging, every time we should check it. So in production, we will not be writing the code directly. We'll be writing main classes, main functions, main code logic within that, and we'll be writing all the test cases. And from that test cases, we'll check all our functions, which we have defined in our main package or main folder. So I hope this is I'm able to convince you why this area is created, and if I'm keeping float and double, so what is this data for? Okay. Now one thing is clear, guys. If you mixed your data type, though they are from same family, but float is having 4 byte and double is having 8 byte. So which one? What will be the return type for area? The return type for area is going to be double. So it always works in that way. It always takes the upper side of value. Okay, because float is having less range than double, that's why it is taking double. If I'm saying integer and long, then it will take long because long is bigger size. So function is created. I feel I sometimes write like this also, but I suggest and recommend strongly that we should create like this. rest is up to you. Compiler will not give you issues, just about the readability. Okay, if you're writing this also, it's not that you're a bad Python Scala programmer. You're a definitely good programmer. Just concising or code expression is a bit missing. Now I want to calculate for one area. Okay, let's say that area is 13.40 length. This is in let's say fit, and width we have total 20.55. So this is length, this is width. Okay, how will you write this up? So you call your function, which is area function, and then write this two things, 13.40 and 20.55. I'm not explaining currently about the when to use float and double. You can use anything. I'm assuming this, that length is float, w is double. There is a range actually. So if you want to check their value, there is a range defined for float and double. Maybe after this functions, I can explain you that. Just wait for a while. Area length value, I will store it as 13.4. Okay, 40. Well, you can write any zero, doesn't make any difference. So 13.4 is fine. And remember, whenever you are writing float, okay, there's a key point to remember, because when I started, in fact, when you start writing these things, maybe you can make a small mistake, and just due to this small syntax, you'll get exceptions. So don't panic, check the error again and again, what this error is saying. If I do not write f last in the float, so if it is float, if it is the float, you have to add this f thing at last. So any variable which has a float data type, it will include f at last. Okay, and comma, second value, which is for double. For double, it does not, we don't need this 20.55. When I multiply, I can get this value 369992160799715. If I keep both as a double, what will happen? If I keep both as a float, what will happen? Not a big difference we're going to see. It's just that, one second, it's just that I'll say f here, and the range will change. This range is coming, the range is big. How much? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14 places after decimal. This is coming because this is double 8 time. My function return type is double. If I change this from double to float, you can see the range is only till 2 decimal. Okay, so you can read the big range also. I do not remember exactly what is the range of float, how much possible value it can take from minus to plus, but number I can tell you. If you are creating any float variable, let's say f1, okay, try creating this 19.980. It is taking till this number, taking this number also. So after decimal, I think it would take any number. Let me do this. Can I copy this part and paste it here? This is still taking double. Let me call this is float. So float is giving you error because range we have crossed. Okay, I will start decreasing from this. I'm just taking a random number, guys. There is no significance with 19980. Just to get the range, I'm trying to, let me keep decreasing this. Still error, maybe error because of this also. 1.9 taking. So I think this will be a good practice, but trial and hit kind of method. Let's go and see here. So instead of doing trial and error, you can search it range of float in Scala. So it's a typical math number. You cannot remember this. Scala range point or Alvin Alexander. You guys can read this. This is the book, soft book. So 0.5 to 0.05. This is the sign, okay? For float, you can have 32-bit IEEE 1.40. So these are the range which you can take up. So this is based on our data set, our application, how, what is our data set, what range we are expecting. So based on that, we'll define whether to take float or double. I'm currently taking random values, float and double. But when we work with a real-time application, I repeat again, we need to know the number, and based on that number, we'll define it. Because if my job can be done using float, then why to give a data type as double? If my job can complete in integer, then why to increase this to long? Because long is anyway taking more space in memory. It is taking more computation time. So whenever you come to performance and optimization side, or you always think about that if I can do my job using this small data type, then why to take big data type? And along with that, you'll have to fit that data set also. So these are few observations which are important. Now I have created one function and given this, similarly, you can create n number of functions. You can do addition, x, y, x plus y, x into y, x minus y. We'll see other parts like default argument. We can see dynamic arguments, all this part on Monday.